Caterine Saleme Ruiz. I was born and raised in Colombia, and I'm an independent researcher in computational mathematics. I've been working on understanding material behavior at the micro scale. So we have different length scales. We have the nanoscale, the atomic scale, the micro scale, and then the macro scale, which is what we can see. There are many phenomena that occurs at the micro scale that we cannot see, but that affects the performance of the material. So brittle materials are fragile. They ceramics, for example, that's the material I study. They have a lot of applications and capabilities, but they have one disadvantage, which is the brittleness. And the idea would be to fix that so we can apply to more everyday situations for improvement of daily life. So you can apply it, for example, for fixing of the teeth. You use materials, ceramic materials for that. But we would like to have strong, inexpensive. We also can apply it for building transportation systems like airplanes or cars. So because they are so brittle, they just with only one, force, you break the whole thing, and you cannot go back. And that's a huge challenge to solve. So with physics, you can understand that and work towards finding relationships between the material properties and the structural properties. So what I do is to study those mechanisms. I try to understand those and see how can I modify or improve in a way that the mechanical performance of the material, it's the one I need for my specific application. So what I do, I use computational tools, mathematical tools, to model those phenomena, like for example fracture at the micro scale, and see how the structure of the material affects the properties of the material. And it's important because in physics you have one part which is making experiments to prove things, to understand things, and sometimes those experiments are difficult to achieve, are very expensive. With computational tools and mathematical tools, you can do the same. You can get insight, you can provide tools, you can predict at a fraction of the cost. Yeah, the idea would be to find a cool solution for that, because for example ceramics is a low-cost material and we have plentiful raw material to make ceramics, and it can be applied to many range of situations, but because of this disadvantage it's not possible nowadays. There are some improvements, but still there are a lot of work to do.